All right, now let's go ahead and just open up 4-3, guys. All right, now there's a lot to do today, a whole lot. Now, again, I went ahead and I just broke down 4-3 for us, the problems I want to do. And then what I did was at the bottom, I just put all of the questions on a different page so we could just go ahead and go down the page, all right, and do them one by one. Because I thought it's kind of annoying when you don't have enough space to work. So I just cut everything up for you so I feel like it would be easier, okay? Now, things that they discovered, all right, that are always true. There are probably 4 or 5 ways to prove triangles are congruent without naming all of the parts congruent, which means the 3 sides and the 3 angles. So today you're going to learn this, that triangles are congruent if all 3 sides are congruent. So what does that mean? That means if I told you to draw a triangle that's 3 inches by 4 inches by 5 inches, everyone in here would draw what? Exactly what? You would draw exactly the same triangle. There's only one triangle that has a side of 3 inches, 4 inches, and 5 inches. Is everybody good with that? Now remember, that's not always the case. All right, that's not always the case. All right, but we say if you have 3 sides of one triangle congruent to 3 sides of another triangle, then the triangles are automatically what? And if they're automatically congruent, that means all of the other parts we say that are corresponding are also congruent. So as soon as you have 3 sides congruent, then you have, or that you know that the 2 triangles are congruent. All right, is everybody good with that explanation? All right, so side, side, side. That's what SSS stands for. Side, side, side. So to prove a triangle is, to prove triangles are congruent, you have to show that all 3 sides are congruent. Now there's another method we're going to learn today, which is SAS. Anybody want to take a guess what that is? That is correct. Side, angle, side. All right. Now, what exactly does that mean? Side, side, side is more obvious, but I'm going to draw a side, angle, side. Side, angle, side, angle, side. All right. Now, notice the angle, please listen, the angle is between the 2 sides. How obvious is that? Because the angle is between the 2 sides. Everybody good with that? So if I said, everybody draw a triangle that's 10 inches and has a 40-degree angle and 7 inches, guess what? Everyone would do what? Draw exactly the same triangle. All right, everyone would draw exactly the same triangle. There's only one triangle that has a side of 10 inches, an angle of 40 degrees, and a side of 7 inches. All right, everyone would draw exactly the same. So over here, as soon as I draw 10 inches and a 40-degree angle and 7 inches, now these 2 triangles are exactly what? Exactly the same. And how do we know they're the same? Because the side, angle, side. All right, side, angle, side. Yes, that is actually a postulate. Thank you. All right. Everybody okay with that? Any questions? All right. So again, that's what we're doing. We're proving triangles are congruent by these 2 methods. Tomorrow we're going to introduce 2 more methods. All right. And again, I feel like it's very simple, but you have to do the proofs. If you don't do the proofs, it's not going to be what? It's not going to be simple. All right. So here we go. Question number 4. All right. Which I took the time of just breaking it up for us, coming down here, writing it in. All right. So now keep in mind, when you're trying to prove triangles are congruent, we are looking for side, 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 or side, angle, side. That's what we're looking for. All right. So let's fill this in now, guys. So obviously I'm lazy, so I'm just going to come over here and I'm going to grab this, copy, and paste. All right. Number one. What's number one? Given. All right, now I want to look. If I was them, I wouldn't mark the figures, but they mark the figures, it seems like. So let's remark them to make sure. So BA, yep, is congruent to DC, and BAC is congruent to this angle. All right, now what we're trying to do is we're trying to prove that BC over here, we're trying to prove BC is equal to DA. Very simple to do. Very simple to do. Yes, sir.
So could you start by saying AB is parallel to DC?
Ooh, yeah, we could definitely say that, but I'm not sure how the parallel is going to help me.
Yes.
Right? We're trying to prove using side, 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 or side, angle, side. Now, you're supposed to be able to see two triangles there, right? All right, so what could I say, AC?
AC bisect.
Why does it bisect?
Because the two angles are congruent.
Now, so bisect means that this angle would be equal to this angle. Reed, help me.
AC is equal to AC.
You are amazing. That is correct. Very good. I appreciate that. So step number 2, we would say AC is congruent to AC. So here we go. And that is, thank you, good job, reflexive. Okay, now what's true about the triangles? Can anybody see that they're congruent? Why are they congruent? Side, angle, side, that's why. So here we go. Number 3, now you got to say it correctly. So we're going to start with triangle ABC. Triangle ABC is congruent to triangle what? Yeah, you guys, you got to make sure you know that now. Again, it matters. Triangle ABC. Now what I do is I look at A. A is the angle. B is like the right angle, or it's the long side. So I can't help you on this. If you can't see it or you're wrong, you got to tell me. CDA. Is everybody okay with CDA? What, Morty?
Well, you said this was a side angle side. Couldn't it also be a side side?
No, because this is what we're trying to prove. We don't know that's true.
Oh, that's what we're trying to prove. Okay.
That's what we're trying to prove.
Okay.
All right, so 3, what did we say 3 was again? Side, angle, side. All right, now are the triangles congruent? Yes, so what's true about all of the parts? They are also congruent. Once you prove the triangles are congruent, the remaining corresponding parts are also what? Congruent. Sam, what's the matter? Do you not see a side, an angle, and a side congruent to a side, angle, and a side?
Well, we haven't. Yes.
You see it now, right? Again, don't be afraid to speak up. I don't care. Speak up if you don't see something. It's better now. If you want to do better on your test, that's what you got to do in class. Speak up. You see it now, right? So as soon as you have a side, angle, side, the triangles are congruent. All right? Now, again, step 4. BC is congruent to DA. Now, we just said that corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. Now, I go on for days and I'm going to talk about CPCTC, and some of you just have no clue what I'm saying. Corresponding parts of congruent triangles are congruent. So we know that those two triangles are congruent, yes? So it's kind of like what we said yesterday. If the triangles are congruent, then all of the what? All of the sides are congruent and all of the angles are congruent. So I could now, if I want to, can you tell me that angle B is congruent to angle D? Yes, because those are what? Corresponding parts of congruent triangles. Now, do I have to say that DC is congruent to AB? No, because we already knew that. Three parts will be that you have to prove three parts are congruent. And then the other three parts will also be what? They will also be congruent. All right, that's really important actually. I don't think that's that bad. All right, is everybody good? All right, here we go. Let's move forward. Let's check out number 5 now. All right, so again, just because we know, copy that, paste it. Number 1. And number 1, that's what? All right, now I like this. The reason I like this is because it's not marked. So we have to mark it. QR is to SR. ST is to what? QT. All right, so again, this one's kind of simple. This one's actually too easy, actually. This one should have been before the last one. What do we got? RT is congruent to RT, and that's what? Reflexive. So now I put 3 tick marks. So now what do we know is true? I ask you what's true. Yay, the triangles are congruent. And the triangles are congruent by what? Side, side, side. Again, I don't understand the difficulty. Right? Now, can I say angle S is congruent to angle Q? By what? Yeah, I was trying to see who could say it already. CT, no. Yeah, you got to say it a couple times. All right, CPCTC. Corresponding parts of congruent triangles are congruent, but this was how simple that problem is. They're not asking for any of the parts. They're just saying, are the triangles congruent? And the triangles are congruent by side, side, side. Thank you very much. Anybody have any issues? Easy. I told you, simple. All right, let's knock out the next one. All right. So now I'm trying to prove ABC is congruent to CD, or I'm sorry, ABC is congruent to ED. It looks kind of obvious, correct? But I either need another what? Angle or a side. All right, so here we go. Of course, I'm just going to put this up here, copy, paste. All right, here we go, number 1. And of course, we would say given. All right, and then I'm going to mark it. So when I took a picture, kind of blurred it. All right. Now, I've used this and I've used this. It says AC bisects BD. Man, what does that mean? Now, tell me this one more time. I'm going to read it to me. Read this. First of all, what does bisect mean? Put your hands down. Cuts it in half into 2 equal parts, right? So now I want you to look at the figure, and I'm going to draw AC, and then I want you to tell me, what does AC bisect? What does AC bisect? BD. So if AC bisects BD, and I'm going to draw BD, so if AC bisects BD, what is true now? Shh, put your hands down. She's got it. AC bisects, what is it bisecting? What is it cutting in half? So what's true? No. Come on, say it. Look up there again. All right. Sorry, I'm going to stand up. This right here, AC bisects BD. So what is true about BD? Cut what? You already told me. Cut in half. So if it is cut in half, what is true?
How about a web search for it?
What's true? One or 2 equal parts. What 2? You have to tell me. Yay, that's all there is to it. All right, not an angle. It wasn't bisecting an angle, right? Come on, I think that's easy. A lot of people don't see it. So again, AC is bisecting BD. That means that what is true again? Tell me, loud and proud. Say it again, I didn't hear. Yes, I'm happy with that. All right, so step 2. All right, here we go. All right, again, when something is bisected, it cuts it into equal parts. If you're not seeing that, you got to tell me. Number 2, BC is congruent to CD. Why is that true? Yes, definition of bisect. Now I mark the figure. 3 tick marks. Come on, that was easy. So now, what is true? There you go. Told you, easy, simple, simple. So triangle ABC is congruent to triangle EDC. Again, why? Yes, we have side, side, side. Yes.
The bisect word to BC also bisects with making the angle.
Has nothing to do with angles. You can bisect an angle or you can bisect a segment. True? Did that help you? You sure? All right, well, tell me again. Come on, I don't want it to be a little bit. I want it to be a lot. AC bisects a segment, not an angle. Right? And some people have this problem. So look right here, guys. Oh, Siri, shut up. All right, so here we go. I'm going to draw this again. Please watch. This right here. I can put it anywhere. Is everybody watching me? I can put it anywhere. Does it change the fact that it bisected BD? No. You see what I'm saying? It's not referring to the angle that it's creating. It's referring to the fact that I drew something and it cut that line segment in half. Is that better now? Yeah. All right. Again, a segment can bisect another segment, or it can bisect an angle. And it's going to come up to bisecting an angle, I think, pretty soon. All right, hopefully you're looking at that going, wow, this is just so simple. All right. All right, here we go. Step number 4, or question number 8, I'm sorry. We're now going to try to prove these triangles are congruent. All right, this is kind of annoying, so here we go. So I need everybody to plot 2, 5. Everybody's got to do that. And then 5, 2. Right, everybody's got to do that. M. Okay, Q, R, S. Do they look congruent? Yeah, they kind of look congruent. Do they agree with me? All right. So this is kind of called a geometric proof. All right. Because we're just going to figure out the measure of each what? Yeah, we're going to measure all 3 sides. And once we show that 3 sides are congruent, then the triangle's automatically what? Congruent. So what we're going to do right now, and I'm going to try to show you how to do this mentally. All right, so this is where we're going to practice our mad math skills. So I want everybody to look up here on the board and make sure you're doing it mentally. All right. Now let's review distance formula. Who can tell me what the distance formula is? What was it? Yeah, brilliant. All right. And that is from what? That's from the Pythagorean theorem. All right. The distance formula is simply derived from the Pythagorean theorem. All right. And we could talk about that more, but again, does everybody remember a squared plus b squared equals c squared? That's for right triangles. All right, that's for right triangles. And we did that last year, all right, when we had right triangles and I asked you to find the hypotenuse or find the leg. And we were working on square roots. All right. So now what we want to do is, for us right over here, I'm going to say the measure of, or I don't need to put measure down. We're going to say, I need to find QR. I need to find RS. And I need to find QS. You bear with me on this. All right. Now, please watch. All right. Because I don't feel like doing the distance formula 6 times. Does everybody agree with that? That's a lot. All right. I don't want it to be a lot. All right. I think it's personally easier to just graph it and kind of look at it. So when everybody look, I'm going to measure QR first. So please watch. Now you're going to miss it. And actually, I'm going to draw this, and hopefully you can see it. If you can't see it, let me know. From here to here, from here to here. Does everybody see I'm creating a right triangle, right? Does everybody agree with that? And right triangles, everybody agree a squared plus b squared equals c squared, right?
Yeah.
Does everybody agree that the length of the hypotenuse is the distance? Anybody have any questions with that? Come on now. Don't fade away on me. What? The hypotenuse is, remember, the one opposite the right angle. That's a right triangle. That's the hypotenuse. Okay? So I want everybody to look at this and say, that's 3 and that's 3. Does everybody agree with that? Right? So what's 3 squared? 9. What's 3 squared? 9 plus 9. And that breaks down to 3 radical 2. Right? Now, come on, guys. Now, you can tell me, how did you get 3 radical 2, right? 18 breaks down. Remember, the square root of 18 breaks down to the square root of 9 times 2. And then the square root of 9 is what? 3. Now listen, I know this is kind of silly, but some of you guys are going to be applying to private schools, and they're going to give you a test. We review in here all throughout the year, constantly. A big part of that test is radicals. That's why I review radicals with you all the time. All right, so if you're not understanding 3 radical 2, we got to talk and review it. I don't care if you don't know, you don't remember. Speak up. Anybody have any questions with what I did there? Everybody good? So I know that QR is 3 radical 2. Now I'm going to find RS. So now watch me draw RS. I don't think you can see that very good. So here is from R to S. Everybody agree with that? All right, so now I'm going to write square root. 1 squared is what? 1. And then this distance is 1, 2, 3, 4, right? 4 squared is 1 plus 16 is square root of 17 is RS. Is everybody happy with that? Everybody good? Now I'm going to do RS. I'm going to, yeah, thank you, QS. I'm going to draw QS now. From here, is QS the same? All right, so now QS, square root of 1 plus 16. And if you can see that, I'm totally fine. You didn't have to do that, but I'm just writing it down. Everybody agree? All right, now what I'm going to do is just to prove to you something, I'm going to go back to QR up here. I'm going to find QR. So here's what everybody else, all your other math teachers are going to make you do. QR is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So now QR is equal to the square root, the square root of x2, which would be -7 minus -4 squared plus 1 minus 4 squared. That becomes a plus. Square root. -7 plus 4 is -3 squared plus -3 squared equals square root of 9 plus 9 equals square root of 18 equals 3 radical 2. Everybody see how tedious that is, right? And some of you are like, well, I'd just much rather do that. And I'd be like, fine, do that. I don't care. Right? I don't care how you do it. All right. But you have to do that how many times? 6 times. All right. To me, I just don't like doing that. Plus, it helps me teach you that the distance formula is just what? A squared plus B squared equals C squared. That's all it is. You're just making right triangles. Do you have any questions with that? What? Yeah. You just want to copy that down real quick? Good job. You can also take a picture of it if you want. All right. Now what we're going to do is we're going to do the other triangle. All right. We're going to do the other triangle real quick. All right. So here we go, guys. Now, for the other triangle, I'm going to do it in a different color. All right. We're going to do, I don't know if that's a good color or not. So I need MN. No, that's a bad color. Oh. MN. I need MO. And I need what? ON. All right, so MN. Get this out of the way. So here we go. MN is from here to here. Everybody good with this? Everybody good? So what do I have? Everybody see this? This is a what? And that's a 3, right? Wasn't that the same as one of the other ones? So don't we know that's what? We know that's 3 radical 2. That's why I like doing it this way, because I can visualize it. Then I'm doing MO from here. Uh-oh. let's do from here to here. Does everybody see that's what? That's radical 17. Good job, guys. I need you to see that. All right, don't take my word for it. And then over here, yeah, it looks the same. Do we agree? Radical 17. So now, are the triangles congruent? The triangles are congruent by side, side, side. Now, I want to write the congruent statement here, guys. I want to write the congruent statement. All right, so I like to do in alphabetical order, P, Q, R, S. So triangle, Q, R, S. Now, QR is 3 radical 2, right? Wow, so this is really an isosceles triangle. Does everybody agree with that? So MO and ON are equal, right? And so over here, which one is 3 radical 2? QR, right? So that would be 2 tick marks. Now, really, because it could be multiple ways of writing this. Hopefully you understand what I'm saying, right? So QR, Q to R to S. So it really could be MNO or what? MMO. Does everybody agree with that? All right, hopefully you understand what I'm saying. So congruent to, as long as we say the 3 radical 2 side first, you're in good shape. MNO. Oh, I forgot the triangle sign. All right, that's kind of annoying. Is everybody good with that? All right, hopefully you're okay with that. All right, let's go down. 1, 2, I only gave you 2 more. So let's just do 1 more because it's annoying. All right, if you want, you cross out 10. All right, just make sure, please, one of those is on the test now. All right, make sure you practice doing that. All right, so just do number 9. All right, my homeschool peeps, just do number 9, cross out number 10. All right, 12, 13, 14, 15. All right, I'll do 1 more with you. Let me look at 14. Let me do 14 with you. All right, and then when I do 14, you guys got to do the other 3. All right, and then we'll talk about it tomorrow and see how you did. All right, but I think it's important for you to try things on your own. Work collectively. All right, let's get this one done. All right, here we go. So again, here we go. I'm going to grab the given and put it in here. All right, number one, given. All right, now I'm going to mark everything. I wish they wouldn't mark it. JM is congruent to K or NK. All right. L is the midpoint of JN, and L is the midpoint of KM. So someone please do tell me, what does that mean? Come on, someone be brave. Go, Kenzie, what does that mean? Step number 2. Yes, definitely, but we already said that. L is the midpoint. So now what I'm asking you now, because L is the midpoint of JN, what is true? Shh, shh, shh. What is, now we're talking. JL is congruent to LN. So let's write that. JL is congruent to LN. And that is called the definition of midpoint. Definition of midpoint. All right. We could also say what, Kenzie? We can also say that KL is congruent to LM. And again, that's step number 3, because I'm lazy. Copy, paste. Same thing. Definition of midpoint. All right. So now I'm marking these 3 things. Now, sometimes I get carried away. I don't even realize what I'm trying to prove. So I like to write on my MJL. MJL. So I'm trying to prove this angle is congruent to KNL, which is this angle right here. All right, so somebody is going to tell me the next step. Come on now, it's boring. The same people have their hands up all the time. Come on, someone else say something. Ruffin, welcome. Why is that? Now, in order to say side, 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 you're proving, you'd have to say that the triangles are congruent. You'd have to say the triangles are congruent. All right, Mr. Valenti, help me or help him. No, 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 no. Come on. Bo. Oh, hold up. I'm going to let someone, after Bo, I'm going to get someone else, my homeschool peeps. Go ahead. No, homeschool peeps. Say something. Harris, is that you?
Yeah.
Tell
Is
me.
it JN is congruent to KM?
You guys are killing me. Killing me.
I know it.
All right, Morty, don't embarrass me.
All right, triangle.
Yay. Wow, brilliant. I'm not saying you're right yet because I need a good corresponding statement. So here we go. He is right. Number 4. Let me write it. Number 4, triangle. Now get the triangles right, Morty. Go. All right, hold on. KNL is congruent to triangle what? What? MJL. I forgot that triangle. Oh, no, I didn't. So let's see if he's right. KNL. KNL. So it's going 1 to 2 to 3. MJL. Yeah, wow. Morty actually got something right. Good job, Morty. Why is that, Morty? Side, side, side. Brilliant. So now, someone else. Come on, I don't want to embarrass anybody. Someone else speak up. Somebody tell me the final step. Yes. Why is that? I want to hear it. Well, that was well said, well stated. I like that. All right, so now you're going to tell me the letters so it's easier. Go. Wow, brilliant. We are great. All right, or you can summarize it like he tried to say. All right, or we can just say CPCTC and be done. All right, that is nice. Very, very nice. All right, so again, some of you guys, you're just going to have to get in the habit. What you're trying to do when you're trying to prove a part, you first have to prove the triangles are congruent. Once you prove the triangles are congruent, then the what? The parts are congruent. All right? Anybody have any doubts? Any questions? Shh. Morty, what? What? Turn around. All right, you finally got something right. Congratulations. All right. So now my homeschool peeps, how's that? Everybody's good? All right, so what we're going to do now is, I know we still have about 13 minutes. All right, I really think it's important for you guys to try some things on your own. All right, I did print out the solutions, but I don't think it's very difficult. All right, you only go to the solutions if you're like, man, I have no clue. All right, I also don't mind you guys talking together. I kind of feel bad. All right, so hopefully you guys are talking to each other. I'm going to end the meeting and I'm going to let you guys talk to each other, and you guys hopefully can share ideas if you would like to do that. All right, you guys have a wonderful day. All right, hold on a second. I got to take care of my piece. Stop share. All right, so I'm going to end, and I'm going to leave the meeting, and of course, we'll put Jude, the responsible one, in charge.
Lorenzo is so responsible.
All right, Jude, keep me posted.